Hi, everybody. Mrs. Scott here. Welcome back. Today, what we're going to do is we are going to compare fractions with unlike denominators, okay? But before we get started, I do want to go over a few things with you. When we're talking about comparing fractions, what is it that we're talking about when we're talking about comparing, not even just fractions, or comparing anything? Comparing. We're usually talking about, I'll give you a hint, three symbols. We are looking at greater than, less than, or equal to. Exactly. Those are what we are talking about when we're looking at comparing, okay? Anytime you hear that word comparing, that's what we're doing, okay? Great clue word right there for you, okay? But now, why would I have to compare, like when comparing fractions, why can't I just simply slide that in? So like, for example, so if I have 1/2 compared to 4/8, why can't I just put a symbol in there? Well, okay, 4 is bigger than 1 and 8 is bigger than 2. So automatically I think, oh, this must be less than. 1/2 must be less than 4/8. Why can't I just do that? Oh, because my denominators are not the same. You're right. We cannot compare fractions with unlike denominators. So what we have to do is we have to find common denominators, okay? And you know what? I'm going to show you the easiest trick ever, okay? So what we're going to do is I'm going to give you just a random problem that I'm going to make up in my head. Actually, you know what? Actually, we're going to do the 1/2. Let's do 1/2 compared to 4/8, okay? Now, when I did it before, I made that prediction that 4/8 was going to be bigger. Let's see if I'm right or wrong, okay? So I know that 2 and 8 are not the same, so I can't just throw in a comparison sign in there. I need to find a common denominator. So how am I going to go about doing that? I am going to go about doing this by using my T-charts, right? Simple as that. I love my T-charts, okay? But this time I'm going to make two, okay? I'm going to make a T-chart for 2, my denominator here, and my T-chart for 8, because I'm trying to find a common denominator between the two. And when I'm finding a common denominator, I am just going to use my multiples, okay? So let's see, let's count by twos. 2, 4, 6, 8, 10. I'm going to stop there, okay? Let's do eights. 8, 16, 24. I'm going to stop there, okay? Because if I look at that, do I have a number that is in both of my list of multiples? That would be a common number. I do. I have an 8 right there, okay? Right there. So my common denominator between both of them is actually going to be 8, okay? Now, you know that Mrs. Cott loves to list down her jumps on the side of her paper because it makes life so much easier, right? So what I'm going to do is I now need to make my 1/2 have a denominator of 8, okay? So what to do with that? What do I do? What do I do? Oh, I'm going to multiply. Yep. And thank gosh I made my chart. So I'm going to write 1/2 is going to be equal to something. I know that I need to have my denominator of 8, okay? So if I look at my chart, 2 down to 8 is going to be, oh, how many jumps? 4. So I'm going to just multiply by 4, right? Because 8 times 4, or I'm sorry, 2 times 4 gives me 8. Okay, so what I do on the denominator, I have to do to the numerator. 1 times 4, 4. Okay, that one's done. Do I have to do anything to my 4/8? I don't, because it already has the common denominator that we found, which is 8. Okay, so now I can look at my fraction. Okay, I know my new fraction is going to be 4/8. Compare it to 4/8. So in this case, what symbol is going to go in there when comparing? Greater than less than or equal to. They are equal. So my guess that I made earlier was not right. So we need to, so that shows us, that shows us the importance of finding common denominators when comparing fractions. So if I go back to my original fraction, 1/2, they are equal, okay? We'll do a few more examples of that too as we get moving on, okay? But what I want to do is I want to show why it's important that we find common denominators when comparing fractions by using a number line, okay? So right now, I'm actually just pulling this right from our problem set, okay? So I'm on problem set 12 and problem 1A. And it says plot the following points on the number line without measuring, okay? Now, how would I go about doing this without measuring? Because I have 1/3, 5/6, and 7/12, right? And if I look at my number line, I'm 0, 1/2, and 1. Okay, well, 1/3, 1/6, or 5/6, and 7/12. They all don't have the same common denominator. So how do I know? I have to find that common denominator. Exactly. So what I'm going to do is I'm going to make a t-chart, but instead this time I'm going to have 3 numbers in my t-chart. I'm going to have 3. I'm going to have 6. And I'm going to have 12. Okay. And then do I list my multiples? Perfect. So I'm just going to do it down. Okay. Help me out. 3, 6, 9. That is not a great angle for me. Sorry, guys. 3, 6, 9, 12, 15. Okay. Now let's do sixes. Okay. 6, 12. Somebody help me out. 18. Right? I'm going to stop there. Now 12s. 12, 24. All right. Now, if I look at this, is there a number that's the same in all 3 of them? I don't have a 3. I have a 6 and a 6, but I don't have a 6 here. I have a 9, no 9s. I have a 12. I have a 12. Oh, there's my winning number. So my common denominator for all of these is going to be 12. Perfect. So now what I have to do is I need to change these to 12. Okay. So if I look at, do I have to do anything to 7/12? No, that one's already done for us. Right? Already done. Leave it alone. All right. But I do have to do something to the 1/3 and to the 5/6. Okay. So how I'm going to do that is I'm just going to make them have be into 12s. Same process that I did with the other problems. Sorry, I don't know if you can see that. Do the same thing, okay? Now, if I go to my 3s, how many jumps till I got to 12? 1, 2, 3, 4. That's a crazy 4, sorry. 4, right? So now I know that I need to multiply by 4. What I do to the numerator, I do to the denominator. 1 times 4 is 4. So 1/3 is equivalent to 4/12. Okay, see what I did there? Same process that I've been doing the whole time. Okay, same thing. All right, now if I look at 5/6, same thing. Go down my 6s. Okay, 6 times 2, because that was my 2 jumps, gave me 12. What I do to the denominator, I do to the numerator. 5 times 2 is 10. So now I know that 5/6 is equal to 10/12. Okay, so now that they are all in 12s, I should be able to kind of plot these on the line a little bit easier, right? Now that I know that my common denominator is 12, I want to look at this 1/2. And what is, if I'm working in 12s, what's half of 12 so that I know, right? It is 6/12. Right? So we know that that's the same. So when plotting these on the line somewhere, I know that this midpoint is 6/12. Okay, so first one, I have 4/12, which is also the 1/3. Okay, if I'm looking at that, is it going to go from 0 to 6/12, or is it going to go from 6/12 to 1? And again, just as a reminder, 1 equals 12/12. Okay, you're right, it's going to go closer to the beginning. Okay, but it's not going to go close to that 0, right? It's 4. So realistically, we're going to want to put it not close on top of the 6, but a little bit of space. So I'm going to put that there, okay? And I'm going to label it the original fraction, just so that I know, 1/3, okay? Now let's look at 10/12. Is that going to go between 0 and 6/12 or 6/12 and 12/12? You're right, 6/12 and 12/12. Same thing. I'm looking at 10, so I'm closer to the 12. I'm a few away, so I'm going to go probably about there, okay? And what I'm going to do is, again, I'm writing my original fraction because that was the number I was given, okay? And then the last one is 7/12. I mean, that's kind of easy, guys, right? It's going to come right after what? 6/12. Beautiful. So we're going to put that one there and 7/12. Okay? There you go. So that's how you would plot three fractions on a number line without having a common denominator. All right. Now, if you look at the second part of the question B, what it does is it actually asks you to compare some fractions. What they have you do is 7/12, and they wanted you to compare that to 1/2. And then they also had 7/12 compared to 5/6. Okay. Now, these answers should be pretty straightforward because what? We already did the work. We already found our common denominators up here. And that's why I stress to you guys finding common denominators, because it's important. It's going to give you more of accuracy on where it is. Okay. And it's going to also make your work so much easier. All right. So if I have 7/12 compared to 1/2, okay, well, we can look on this line. We know that 1/2 is 6/12. Which one's bigger? 7/12. So 7/12 is greater than 1/2. Okay. And then 7/12 compared to 5/6. Ooh, 5/6 equals what, everybody? 10/12. We already know that. 10/12. So what we're going to do there is that 7/12 is less than 5/6. Okay. All right. So that is how you would do the number line problems. All right. And I tell you guys this all the time. Math only gets longer. It doesn't get harder, it gets longer. Okay. This took us a lot of steps, but in the end, we were able to easily plot all of our points, easily answer our questions related to that. Okay. Again, T-charts, use them for everything. Okay. So now what I'm going to do is I'm going to move on to 3. All right. I'm going to move on to problem 3. And all that is that it says compare the fractions given below by writing greater than or less than on the lines. Okay. Then it says give a brief explanation for your answer for referring to the benchmarks of 1/2, 0, 1/2, or 1. Okay. Now, absolutely write those little blurbs and everything. However, I have told my kids too that by doing the work, that also is a great explanation because your math is going to do the talking for you. Okay. So I am going to look at 3A. All right. And I've already kind of gave you example on how we're going to go about doing this. So I'm on 3A. All right. And that's 1/2 compared to 3/4. Okay. Now we can look at this. Okay. And we can think, okay, if I didn't want to do any math, I could say, okay, if I'm working in 4, okay, what is 1/2 of 4? 2. So 1/2 of 4 would really be 2/4, okay? And in this case, 3 is bigger than 2, okay? But hey, say what if I didn't know that? What if I was like, oh man, okay, I don't know. Let's do the work. Let's show the work, all right? I have 1/2 and I have 3/4. Can I just compare them? No way, Jose. I got to find my common denominator. So I'm going to make my T-charts, which I love, and I'm going to list my multiples. 2, 4, 6. Stop in there. 4, 8. What's our common denominator? Boom. 8 or 4. I'm sorry. I said 8, but I circled 4. 4. Okay. Do I have to do anything to 3/4? Nope. It's already a 4. Do I have to do something to the 1/2? You bet your bottom dollar I do. So what I have to do is I have to take 1/2 and I need to make it into fourths. Okay. So if I look at my T chart, what am I multiplying by? 1, 2, multiplying by 2. 2 times 2 equals 4. Now what I do to the numerator or the denominator, I have to do to the numerator. 1 times 2 is 2. So now I'm comparing 2/4 compared to 3/4. What symbol is going to go in there? Less than, absolutely. Because 1/2 is less than 3/4 because 1/2 is equivalent to 2/4. Okay? So I'm only going to do one of the examples in this lesson because in the next lesson, we're going to do a few more as well. Okay? So that is all I have for lesson 12. I'm now going to move into lesson 13. Okay? I just have to clear my boards. So problem set 13 is going to look very, very, very similar to problem set 12. Only this time, we are moving our comparison number line, all right? The first one, when we compared, we were comparing our fractions that were between 0 and 1. So now what would we do if we have a fraction that is bigger than 1 whole? All right, what would I do there? Well, I'm going to show you. All right, so now that my boards are cleared, let's look at that, okay? So if we look at our problem set, okay, I'm on our problem set for lesson 13, all right? So lesson 13's problem set, okay? And I'm going to do 1A with you, all right? So if you look at that number line this time, like I said before, it's from 1 to 2, and the middle point is 1.5, okay? And our problems that we are working with, or our fractions that we are working with, are 4/3, 11/6, and 17/12. Ooh, I kind of already noticed something. Maybe it's similar to the last lesson. I don't know. Okay, but here are my fractions, just like that. Okay, now, what's something funky about my fractions? 4/3, 11/12, and 17/12. All of the numerators are bigger than the denominators. What does that mean? They're improper. Perfect. You got it. Improper. However, that's a totally different lesson. So I'm not going to get into that now. Okay. What I am going to do is we're going to first do what? We're going to follow the same process that we did the last time, right? Okay. We're going to follow that whole process. Same thing, right? Even though we know these are improper and we know that our numbers are greater than 1, I'm not going to worry about that right now because first I need to compare my fractions, right? So in this case, I still need to find my common denominator, okay? So again, I'm going to make that 3-way T-chart. And what's nice about this one is it's the same exact numbers that we had last time. And I was like, ta-da! We have 3, 6, and 12. And we already know that what is our common denominator between 3, 6, and 12? I'm just going to quickly write them for us so that we know. But it's, if I do my 3s, 3, 6, 9, 12. If I do my 6s, 6, 12. If I do my 12s, 12. So we already know that our common denominator for all of these are 12, okay? Which means I can leave 17/12 alone because I already have that common denominator of 12, okay? So I have to change 4/3 and 11/6 into 12. So let's do that, okay? We do the same thing that we have been doing, okay? So 3 times, oops, I forgot my numbers. 3 times 4 equals 12. So I know that I'm multiplying by 4. What I do to the numerator, I have to do to the denominator. I always say that backwards. The denominator to the numerator. Okay? So 4/3 we know equals 16/12. Perfect. Okay. So now let's look at this one. 6 times 2 gave me 12. So I know that I'm multiplying by 2 on the numerator and the denominator. 11 times 2 is 22. Okay. And I know that 11/6 equals 22/12. Okay. And again, 17/12 already done for you. Don't have to do anything with it. All set. Okay. So now I have to, again, plot these on the number line. Okay. Let's now look at the number line and figure out, okay, how am I going to plot these? Where are they going to go? Okay. Let's fill in some information that we know of. Okay. We know that we're all going to be in 12ths. Good. 1 whole of 12s equals what? 12/12. Good. 12/12. Okay. Now, how am I going to figure out what 1/2, 1 and 1/2 is in 12ths? Well, that's easy. It's just 12 plus half of 12, which is 6. So what that means is that this one's going to look at 12. 12 plus 6 equals 18. Okay, I'm going to erase that. So I know that 1 and 1/2 equals 18/12. And then 2 is 12 plus 12, which is 24/12. Okay, so it's just taking the information that we already know in our brains and just using our math, our adding, and all of that to figure out what goes where on these number lines. Okay, so now can we plot them? You bet your bottom dollar we can. Okay, let's look at our first one. So our first one is 4/3, and we found out that 4/3 is equal to 16/12. Okay, so we're gonna have to plot that somewhere. We're looking at 12/12, 18/12, and 24/12. Okay, again, I'm talking in 12s because it's easier for me to think of that number line in 12s. Okay, because that's the fraction we're looking at. Okay, so 16 is smaller than 18, but a little bigger than 12. So we're probably going to be, again, close, just a little bit away right there. Okay. But remember, when plotting these, you want to write the fraction that they gave you. Okay. 4/3. Okay. Now I have 22/12. All right. That's definitely going to be in between 18/12 and 24/12, right? Because I have 22. Again, we're just a little bit off of that first one, or that I'm gonna go a little deeper. But we know that that's there, so that is 11/6 would go there. Okay. Again, just use your eyeball and your judgment. Be kind of little aware, a little bit conscious, okay? So this is only 2 ticks away from that, so I want to be close to that. Okay. And then our last one is 17/12. Well, where's 17 going to fall in relation to 16/12 and 1 and 1/2, which is 18/12? Right in the middle of it. Perfect. And we're going to write 17/12. Okay. Again, looks like a lot of work, but all of your work is done when you find your common denominators. Okay. I can't stress that enough to you. All right. Now we're going to look at the second part of that because it did ask us to compare 1 and 5/6. And 1 and 5. So you know what? I'm going to pause on that part, and we're going to do that one a little bit later together on that one part. The one in the part B, use the number line in problem 1 to compare the fractions. I'm going to skip that part for now. Okay. So again, just kind of moving forward, this is the work that you would have to do to help plot these fractions that don't have common denominators. All right. Now, what if I don't have a fraction line? And now, guys, I'm looking at problem 5 on problem set 13. Okay. So I'm working at problem 5, and I'm going to do A. All right. So problem 5A, again, lesson 13. Okay. So now all of a sudden they're giving you a fraction to compare. They're giving you 3/8 to compare to 7/12, but there's no number line. What do I have to do? To find my common denominator. And I keep coming back to it. I'm going to use my T-chart. Always using that T-chart. And you know, it helps us. It's a fantastic tool. Use it over and over again. Okay, I get my two denominators and I put them next to each other in my T-chart, right? And now I'm going to skip count. I'm going to list my multiples. My multiples of 8 are 8, 16, 24, 32, okay? And I'm going to write my jumps because I tend to forget that when I'm making these videos, okay? Put my jumps next to it. Now I'm going to do my 12s. 12, 24, 36. I'm going to stop there, put my jumps, okay? What number is in both of them that we could use that's common? It is 24, okay? So now I have to change both denominators, okay? In the problem before, we haven't had to change both denominators. So now we're going to have to do both of them, okay? So I'm going to put this down because my hand hurts holding it up. All right, so now I know that I need a new denominator here, and I know that I'm going to need a new denominator here, and we already picked it out. It is 24, so I'm going to write that in. I know that my new denominator is 24, okay? Now, I need to figure out, okay, I'm looking at 8. 8 times what number jump gave me 24? Times 3, okay? So I say this all the time. What I do to the denominator, I have to do to the numerator. So I'm multiplying by 3 because 8 times 3 gave me 24. What's 3 times 3 going to give me? 9. Perfect. 9. Okay, now I have to do the same thing for 12. Okay, 12 times what number gave me 24? 12 times 2 jumps gave me 24. What I do to the denominator, I do to the numerator. 7 times 2, 14. Okay, so now my new fractions that I'm comparing, and this is important. Okay, so don't get confused too. All right. Sometimes I like to box them in so that it makes it a little bit easier for me to see. Okay. Now I'm comparing 9/24 compared to 14/24. Okay. What am I going to use to put in there? It's going to be less than. So in this case, 3/8 is less than 7/12. Okay. And here's my work. Okay. My work is my explaining. All right. Let's do another one like that, okay? Because I think that these ones can be a little bit trickier, okay? So let's do, I'm actually going to jump to E right now, okay? I'm going to jump to E. Beep, beep, beep. Okay, so E looks like 7/5 compared to 11/10, okay? All right, just looking at them, we already know I don't have a common denominator here. I have to find it. Handy dandy T-chart. 5 and 10. Okay. Skip counting by 5s. 5, 10. Oh, that looks familiar. 10. My common denominator is 10. Yep. So now I don't have to do anything to 11/10, do I? Nope. I'm leaving it alone, but I have to do something to this one because this now has to become a 10. Okay. And how many jumps was that? 2. So I'm multiplying by 2. 7 times 2, 14. So now I have 14/10 compared to 11/10. And in this case, it is going to be greater than. All right. So in the end, 7/5 is greater than 11/10. Okay. So that is really all I have for you guys for lessons 12 and 13. All right. Now, please feel free to reach out with any questions you have and keep trying, okay? When in doubt, T-chart it out with multiples. All right. Have a good one, guys. Bye.